In this video, I'm going to talk about Newton's method. This is a special method that helps us find the root of a function. By that, what do I mean? Let's consider an example. Let's consider that our function is f of x is equal to x squared minus 2. We would like to find out where the value of this function is 0. That means y is equal to 0. So we just set the function to 0, x squared minus 2 is equal to 0. And solving for x, we get square root of 2, which, by the way, is approximately 1.414213562 ... It's an irrational number, as you know. You cannot be expressing it in terms of a finite number of digits after decimal. However, the question is this. If I were to ask you, what is this value, square root of 2? You may say that put it in the calculator or put it in a computer program, it will give it to you. However, before a calculator or a computer can do it, we humans must have to be able to do it. Otherwise, we can't program it into a calculator, or we cannot program it in a computer either. Okay? So now, how do we go about finding this value, or rather, how do we go about approximating this value? So this is where Newton's method comes into play. So let's go ahead and consider this arbitrary function. This is some general function. It's not square root of x. It's not the x squared minus 2 function. Okay, so now let's go ahead and look at this function. So let's say this function looks like this. Okay, this is my f of x. And this is the point I'm interested in, this point. Okay, what is the x value for this function? That will give you f of x is equal to 0. That means I am trying to find the root of this function. The way we do it is by applying Newton's method. So let's pick a random point, okay? Let's call this point. So associated with this point, I have x1, point x1. So this is going to be x1 comma f of x1. Now what I'm going to do, I'm going to draw a tangent line to this point. So tangent line to this point. This tangent line intersects the x-axis at a point, let's label it x2. Now, what is the equation of this tangent line? Which is very easy. That's the slope of the function, right? So f prime of x1. So the slope of the tangent line at point x1 and f of x1 is this. It's a straight line, so the equation must be y2 minus y1 divided by x2 minus x1. Now, note that my x1, y1 is this, okay? But the tangent line intersects the x-axis right here, so at point x2. So at that point, my y2 is going to be nothing but 0. So something that you have to remember, because we are trying to find the slope of this tangent line, which is a straight line, right? y2 minus y1 divided by x2 minus x1. y1 and y2 are points on the straight line, and x1 and x2 are the corresponding points. Only interesting observation here is this. At this point, x1, f of x1, the line is a tangent to the function. So the value of y at this point is going to be f of x1, whereas the value of y at point x2 is going to be 0 because it intersects the x-axis at that point. So if I were to rewrite it, I'm going to get f prime of x1 is equal to negative y1, but negative y1 is f of x1 divided by x2 minus x1. Now I can simplify it by making the assumption that f prime of x1 is not equal to 0. Then I could rewrite it as x2 minus x1 is equal to negative f of x1 over f prime of x1. If I were to rewrite it, I'm going to get x2 is equal to x1 minus f of x1 divided by f prime of x1. Now I can take this idea and extend it. So let's say associated with point x2, this is the f of x2. So then I can draw another tangent line right here. Is gonna give me this point, which is x3. Okay, and repeating this process, I can keep going closer and closer to the desired point. And so we can rewrite this formula as a general term or general formula. X sub n plus 1 is equal to x sub n minus f of xn divided by, this is n, f prime of x sub n. And I can use this formula to get arbitrarily close to the desired point, which is this point, where f of x is going to be 0. Now let's go ahead and take this function, take this concept, Newton's method, and apply it to this function, where the x squared minus 2 is equal to 0. So what my f of x is x squared minus 2, and my f prime of x is just 2x, right? So I'm gonna use the formula. So let's say I start off with x1 is equal to 1. Very simple. You can start, this is a random point. You can start anywhere you want. So x1 is equal to this. So what is my x2 gonna be? x2 is gonna be x1 minus f of x1 divided by f prime of x1. Now x1 is 1 minus f of x1. So f of x1 is going to give me 1 square minus 2, which is negative 1, right? So negative 1 divided by 2 times 1, which is the f prime of x evaluated at x1 equal to 1. So that's going to give me, by the way, guys, x2 is equal to 1 plus 1 over 2. Because negative and negative is going to make it positive, which is just 1.5 x2. Now let's go ahead and find x3. Is going to be x2 minus f of x2 divided by f prime of x2. So my x sub 2 is going to be 1.5. So 1.5 minus f of x2, so which is going to be 1.5 whole square minus 2 divided by f prime of x2. So I evaluate this at 1.5. So 2 times 1.5. And you can simplify it very easily. If you simplify it, this is what you should get. You will get 1.41, 6666. Actually, you can keep going as many sixes as you want, and if you round it, it's gonna give you 7. As you can see, already we are getting very close to this number, the square root of 2. Now we have done it for x1, x2, x3, right? So we can keep going up to xn, and depending on how much accuracy we want, we can keep going up to that level, or my n could be maybe 10, 15, 20, depending on how much accuracy I want. By the way, if you do it by hand, this calculation could get messy and a little bit complex. However, if you use a calculator, it will do it very fast for you. Or if you write a computer program for doing this, it's going to do it very fast. So this is how Newton's method works. Okay. In essence, we start off at some point, find the slope of the function at that point, and we keep going. We keep repeating that process, and then we find the next point, and we keep doing it until we get arbitrarily close to the desired point, and it depends on how much accuracy we want. So I hope that this discussion was helpful. Thank you very much.